This is an A-level pure question on sigma notation and recurrence relations. Part 1, we need to show that the sum from r equals 1 to 16 of 3 plus 5r plus 2 to the power r is equal to 131,798. Now, whenever we got these summations, if you see something that looks a bit like the first part, so you've got r multiplied by something, so let me just highlight that bit, this bit here, that tends to be like an arithmetic series. Yeah, if I'll spell it correctly, arithmetic, not arithmetric. Okay, when you see r multiplied by something. Now when you see r to a power, or r is a power, then you should be thinking geometric. So I've actually got an arithmetic and geometric series or progression here. So I want to add these separately. I'm not going to try and do them together because I've got two types of sequences going on. Now I just want to prove to myself that is actually what's happening. So if I start with the 3 plus 5r, and I'm doing the sum of that from 1 to 16. So this is just to prove that this first bit here, the bit in red, is actually arithmetic. So the first term of that will be 3 plus 5 times 1, 8. Second term, 3 plus 5 times 2, 13. And then 3 plus 5 times 3, 18. And then 23 and so on. Okay, I can see that this is arithmetic with a first term of 8 and a common difference of 5. So I think I've proved to myself this first bit is arithmetic. How about the 2 to the power r? Let's have a look at that. So the sum of r equals 1 to 16 of 2 to the power r. Let's substitute in the powers of r and see what goes on. So the first term, 2 to the power 1, is just 2. Second term, 2 squared. Then 2 cubed. Then 2 to the power 4 and so on. Okay, I can see that this one is indeed geometric. I'm timesing by 2 to get the next term. So here, a is equal to 2 and the common ratio is equal to 2. And for both, the number of terms is going to be 16. So what I can do is to say this, that the sum from r equals 1 to 16 of 3 plus 5 to the power of 5 times r plus 2 to the power r is equal to the sum from r equals 1 to 16 of 3 plus 5r plus the same sum from r equals 1 to 16 of 2 to the power r. So I've got an arithmetic plus a geometric. So now let's work out what that's going to give us. Right, so for the arithmetic bit, I'll use the formula, the sum of n terms is n over 2 times by 2a plus n minus 1 d for this part here. So the sum of 16 terms will be 16 over 2 and then 2 times the first term. Okay, well that is 8 plus n minus 1, that's 15, times by d, the common difference, which is 5. Okay, so that will give me the sum of my arithmetic, and then plus the sum of my geometric. And to find the sum of a geometric, I'm going to use a times by 1 minus r to the n, or it could be r to the n minus 1 over 1 minus r. Again, that could be r minus 1. It doesn't matter which form I use, I'll just use this for now. I think this is the one that's in the form of the book, but you can flip it around if needed. So here, a is going to be 2, that's the first term of my geometric, times by 1 minus r is also 2, yeah, and n is 16. So 2 to the power 16 over 1 minus 2. So let's work out what we get for each part of that. So the sum of my arithmetic is 728, and the sum of my geometric is 131,070. So we'll add those two together and we get 131,798 as required. Part 2. A sequence u1, u2, u3 is defined by un plus 1 is equal to 1 over un, where u1 is equal to 2/3. What we need to do is to find the exact value of the sum of, from r equals 1 to 100, ur. Now, whenever you get these types of questions, it's often that the sequence produced by the recurrence relation is periodic. So we get the same terms occurring over and over again. And it's normally fairly straightforward to find the sum of those repeating terms. Now, to see if it's periodic or not, we need to work out what those terms are. So u1 has been given, that's 2/3. So we're now going to work out u2, and using the recurrence relation, u2 is going to be 1 over the previous term, which is 2/3. So that gives me the next term as 3 over 2. Right, u3, that's 1 over the previous term, which is 3 over 2, and that gives 2/3. So you can probably see what's happening. I'll just do one more. u4, 1 over the previous term, 2/3, and you end up with 3 over 2. So the sum of these 100 terms, ur, is going to be 2/3 plus 3 over 2 plus 2/3 plus 3 over 2, and so on. And actually, I'm going to end up, the last term is going to be 3 over 2. So I'll just put plus 2/3 plus 3 over 2. So what have we got here? Well, I've got 50 of those 2/3 to add up. So I've got 50 times by 2/3. And then I've also got 50 lots of 3 over 2. So you can see it's very straightforward to work out. Look for this repeating pattern when you're adding lots and lots of terms together with recurrence relations, often periodic. So this has a period of 2. It repeats every other term. So let's add this up and we should get our answer. So 50 times by 2/3 is 100 over 3, plus 50 times by 3 over 2, that gives 75. So we'll add the two together and we get 325 over 3. Now, I'm not going to change that to a decimal because the question does say exact value. So I will leave my answer like that, 325 over 3.